Okay, we're going to talk about another way that we can write these ionic formulas. Okay, so the first thing we're going to do is quickly look at our periodic table. Notice how I still have the number of valence electrons up there. Okay, but this method we don't need the number of valence electrons, we need the charge that they're going to form. But there's an easy way. So when you have one valence electron, they could either gain 7 to get to my 8 or get rid of that 1. What they're going to do is get rid of the 1. So all of group 1 will form a +1 charge. Group 2 has 2 valence. So either going to give up those 2 or gain 6. It's going to be easier for them to give up the 2, so it's going to be a +2 charge. We then move over to group 13. They have 3 valence, so it's either going to lose 3 or gain 5, and it's going to be a +3 charge. 4, here's my middle of the road. It's either going to lose 4 or gain 4. Well, this one is middle. It could either do either one. So we're going to put ±4. Group 15 has 5 valence, so it's either going to lose the 5 or gain the 3. So here it's actually going to gain 3 to be a -3. Group 16 has 6 valence. It's either going to lose the 6 or gain 2. It's going to gain 2 for a charge of -2. And group 17, it's either going to lose 7 or gain 1. It's going to gain 1. Then group 18 already has 8 valence, and he's perfectly happy, so he really doesn't want to do anything. If you do not have these charges already on the periodic table, I highly, highly, highly suggest that you put them on there right now. So now we're going to work on another method. I like to refer to this as the switcheroo. You can use the Lewis dot structure one, but here, honestly, most people refer and like to do the switcheroo method. So the first thing that we have to do is write the symbols. So sodium is Na, chlorine is Cl. And looking at my periodic table, sodium over here has a charge of +1, so I'm going to put a +1 here. Chlorine is way over here, has a charge of -1, so we're going to put a -1. So the whole point of this is trying to get a total charge of 0. In this case, it's the switcheroo, so I'm going to take this and bring it down here, and take this and bring it down here. And when we do the switcheroo, we essentially get rid of the positive and negative, so it would be Na1Cl1. However, remember though, the 1 and 1, we really don't need it, so it's NaCl. Let's look at aluminum and phosphide. Aluminum is Al. Phosphide is phosphorus, so it's P. So aluminum is right here. It's a +3 charge. And phosphorus is right here, which is a -3. And if we do the switcheroo, it ends up being Al3P3. However, when you see this where it's the same subscript, the 3 and a 3, we can reduce them to a 1 and a 1. So that would be ALP. Same thing as if I had a 2 here and a 4 here, I could reduce that to a 1 and a 2. Let's look at magnesium oxide. Magnesium and oxygen. Magnesium's right here, charge of +2. Oxygen is -2, so it ends up being Mg2O2, but notice how my subscripts are the same, so it's MgO. Let's go down to this one. I'm going to skip cesium and fluorine right now. We're going to do strontium and nitride. So strontium is way down here. It's in group 2, so it's a +2. Nitrogen is right here. It's in group 15, so it's going to be a -3. Pulling the switcheroo, it becomes SR3N2. Okay, so the switcheroo method, when you write the charges and then you bring them down, notice how I did not bring down the pluses and the minus. We just make them essentially all positive. So now what I want you guys to do is work on pages 8 and 9 of your book of fun. And please do not hesitate to ask questions.